Cool. Hey viewers, I'm Ben from the Nova Rover chassis team. So I've decided to put together some CAD tutorials for the team. So I'm going to start making some videos on how to model the suspension system in SolidWorks. So this is a bit of a quick project for anyone on the team who wants to learn a bit of CAD, and just anyone who wants to learn CAD in general. So if they go well, might make some more videos on the chassis body and the wheels, and so on. I guess I just want to encourage anyone who's learnt something on the team as well, just to think about making some videos. Pretty easy to put together, and I think it's a really, really good way to pass on some of the skills you've learnt to some of the new recruits. Cool, so we'll see how we go with these videos. I hope this will be a good resource as well for other URC teams, and just anyone who wants to learn how to use SolidWorks in general. Cool, so here's a great image of our rover at the 2021 Australian Rover Challenge to get us started. So you can see the big orange wheels, and we got the suspension system there as well. So basically that's what the rover looks like in real life, and this is what the suspension system CAD model looks like on the left here. So you can sort of see what the suspension system involves. So essentially this is the CAD model of the suspension system that we're going to be working with. This is what it looks like on its own without all the other sort of modules. We developed this in 2018 and we've used it over the last couple of years. It's basically just a passive 4-bar mechanism on both sides, and it allows each of the wheels to sit at an independent level on an uneven surface. Sort of similar in principle to the NASA rocker bogie. Essentially it ensures all the wheels keep in contact with an uneven ground surface, and basically tries to keep the mass distributed across all the wheels as evenly as possible as well to maximize traction. Cool, so basically not sure how many videos there are going to be yet. We'll probably have one video per part, and I'll try to sort of explain not just how to draw the part, but also why the part was drawn in a certain way and where we got the dimensions from. So we'll be doing some Google searching, we'll be downloading some parts, we'll be looking up data sheets, that kind of thing as well. So hopefully it should be like the whole sort of explanation. I guess just pointing out the obvious, these are going to be highly informal, not really training quality. I'm not going to be editing these, there's just going to be all in one take. So some will be higher quality than others. But I think that should allow me to push out more videos more quickly as well, which I think is beneficial. So it's basically just going to be me recording myself modeling the parts, and I'll try and drop in some sort of commentary along the way to sort of help out. The CAD might be painfully slow for some people or too fast for others, so feel free to speed it up or pause it and that kind of thing. If you got like the multi-monitors set up, that might be good as well, so you can have SolidWorks on one side and the tutorial on the other, so you can jump back and forth. So I guess I'm going to be referencing this existing CAD model here throughout the series. Don't worry if you don't have this model, you can basically just sketch along with me and put in the dimensions that I type in as we go along. Cool, so pretty much all you guys are going to need is a SolidWorks installation and a computer with internet access. So for the Monash students, I'll drop a link to where you can download and install SolidWorks in the description. I'm guessing most of you already have that, but I'll put that down there anyway. And so I hope these videos are helpful, bit of fun even, and feel free to reach out to me and pretty much anyone else in the team if you're stuck and you need a hand with anything. Cool. So best of luck.